Hello, and welcome to Solubility FRQ Practice with Alexander Mesher. Today we are going to be going over a 2015 AP Chemistry free response question. This is one of the shorter questions on the exam, of which there are 4, and the recommended time for this question is about 15 minutes. Alright, so go ahead and pause the video here and try this on your own, and then we will go over it. Alright, now that you've tried this on your own, let's go ahead and talk about it. Alright, Part A. Part A says, write a balanced chemical equation for the dissolution of calcium hydroxide in pure water. Now, this is a pretty straightforward dissolution equation. You guys should be able to do this. So let's just see what the answer is. Alright, so as you can see here, calcium hydroxide is going to dissolve into Ca2+ ions as well as 2 hydroxide ions. So what is important to write in this equation is to have the ion charges. So you need to have a 2+ on the calcium ion because it has a positive 2 charge, as well as a minus on the OH ion. Additionally, we can see that in the product, in the reactants, there is 1 calcium and there are 2 hydroxide ions. So there will be 1 calcium in the products and 2 hydroxide ions in the products. Hopefully that's pretty straightforward for you guys. Alright, for Part B. Part B says, calculate the molar solubility of calcium hydroxide in a 0.1 molar calcium nitrate solution. Alright, so the first thing that we need to do, let's talk about what they're asking here. Alright, so really they're trying to get at setting up a solubility expression. And they're also including a common ion in the form of calcium nitrate. So as you can see, calcium is shared in both of these ionic compounds. So the amount of calcium that is provided by the calcium nitrate is going to affect the solubility of the calcium hydroxide in the solution. Alright, so first we set up a solubility expression, solubility equilibrium expression. And in this expression we include the 2 products because the reactant is a solid. So we include those 2 products, which are calcium 2+, of which there's only 1, so you just write the concentration like that right there. And then there are 2 OH- ions. So as we do in all equilibrium expressions, we're going to raise the concentration to the coefficient. So as we can see here, hydroxide has a coefficient of 2, so we're going to raise that in the solubility expression to the power of 2. Now that we have our solubility expression, we can plug everything in. So here we plugged in the KSP, which we were given at the beginning of the problem, which is 1.3 times 10 to the negative 6. Here we plug in the concentration of calcium 2+. So here we're going to account for the existing 0.1 molar calcium provided by the calcium nitrate. Then we're going to add that to our unknown concentration of calcium that dissolves from the calcium hydroxide. And then here we have 2 times the concentration of OH- because it has a coefficient of 2 here, and we're going to square that. Alright, so something important to note in these kinds of problems with a common ion is that you can cancel out this x. And that removes a lot of extra work, setting up, in this case, quadratic equation to try to solve this. You don't have to do that. You just cancel this x out because it's much smaller than the 0.1 here, so it's really not going to matter in the end in the math. So we're just going to get rid of that x, and that leaves us with approximately 0.1 times 4x squared. Here we just went ahead and squared the 2 so we could remove the brackets, and we left the squared on the x term. Alright, so now we're going to solve for x. So first we divide 1.3 times 10 to the negative 6 by 0.1. That gives us 1.3 times 10 to the negative 5 equals 4x squared. Then we're just going to plug that in the calculator, and we get x equals 0.0018 molar. And that is our answer. The molar solubility of calcium hydroxide is 0.0018 molar. Alright, on to part C. Part C says, in the box below, complete a particle representation diagram that includes 4 water molecules with proper orientation around the Ca2 plus ion. Represent the water molecules as this shape right here. So, in this question, they would like us to draw 4 water molecules that are in the correct orientation according to their polarity around this ion. So the first thing that we need to know here is that water is a polar molecule. And we know that because it is an uneven shape. So water has a positive and a negative pole. The negative pole is near the more electronegative oxygen, and the positive pole, which is directly across from the negative pole, is near the hydrogens. So as we can see here, hydrogens have the positive charge and the oxygen has the negative charge. Now, we also know that unlike charges attract each other. So we can see here that the calcium 2 plus ion has a positive charge. So the H2O molecule is going to be oriented so that the negative charge of the oxygen is facing the positive charge of the calcium 2 plus ion, as shown here. Make sure that you draw 4 molecules because that is what asked in the question, and make sure that all of their negative poles are pointed towards the calcium 2 plus ion. Alright, thank you for watching, and good luck studying.